Question number 17. A soil specimen. Thickness of the soil specimen is 20 millimeter thick. Was taken from a site where a 6 meter thick uniform deposits of clay overlays impermeable rock. Okay, the specimen was installed in an odometer apparatus with an initial effective stress of 30. This is the initial effective stress. The total stress was then increased to P70. So now we have here very important information, which is the change in the stress, in the vertical stress, is equal to 40 watt, 40 kBA. Okay, and the following specimen height versus time data was obtained. So we have here this thickness, this is the specimen thickness, and here time. If the odometer specimen is able to drain definitely from top and bottom, this is actually the normal situation in the lab. So I ask you to estimate the CV, MV, and K. Right, if we have this type of question with this information, so what we're going to do, we are going to plot what? Plot the specimen thickness versus time, as we can see here. But this is just an example. I mean, we are not using the real data. Okay, here in the x-axis, we have what? The square roots of the time. And what we have here, we have the, maybe we can have here the thickness or the dial reading, whatever things is, you can put here the thickness of the sample. So we can start here, look the data that we have here 20s and 19, okay, so I can start here by 20s and 19s and 18, and then you start plotting, okay, your data, as you can see, something like that, okay. And since we are plotting our results like that, which is square root time versus what versus the settlement, so this is actually what we can call it as a Taylor technique, okay, for what? For finding the CV. Okay, once you plot the points, the method said, okay, try to find what? Try to find the straight portion of this curve. You see this red curve? Okay, so we said, okay, now try to find the straight portion. Once you find the straight portion, draw a line like that, okay, then this line with at any distance like that, okay, multiply it by 1.15 and what? And because this line is like that, and draw what? Draw a line from these points, because these points will be what? It will be x times 1.15, as we explained in the lecture. Then you can now draw another line like that, which is starting from the same points here, but you see it is shifted a little bit, okay, with this value which is 0.15x. So we have this distance multiplied by 1.15, you get this one here. Okay, the points here is now the green line when intersect with the curve, which is at these points. Okay, we can say this is the time where we have what? When we have 90% degree of consolidation. So now we know the time at which we have 90% degree of consolidation. We have this equation, okay, where we said now, okay, we know what is the time for what? For 90% degree of consolidation. So this is already known for 90% degree of consolidation. Okay, we said that the drainage length here, it should be what? It should be about 10 millimeter. Why it is 10 millimeter? Because he told me the specimen is 20 millimeter and it is drained from both sides. Okay, then what is now the time factor for what? For 90% degree of consolidation. This is a value which is known from the table 8.48. So simply now I can get what is a CV from this equation and using what? The time for 90% degree of consolidation here. Okay, what is the second requirement that we have here, which is MV? Okay, what is the equation that we can have for MV? MV could be equal to delta H divided by H naught times what? Change in the effective stress. What is the change in thickness? Okay, the change in the thickness is the difference between this value and this value, because this is a change in the thickness that we have. So this is could be what? This is could be 1.2. Right. What is the change in the stress? The change in the stress is this value. Right. What is H naught that we have? It was 20 millimeter. So you can now get MV. Now the third requirement is K. Okay. K is what? Is the hydraulic conductivity. Right, so let us go to the formula sheet, and we said by knowing MV, by knowing CV, because this is what we get. Gamma water is already known. We can get K, and this will be the hydraulic conductivity. Thank you very much.